Hey, I'm Bryson Smith. We're back out here in the fab shop at Trick Tools. We have a 70 Camaro drag car here that a customer asked us if we could build a custom set of headers for. And we thought it'd be a great opportunity to show you guys the header building process, as well as some of the tools that we sell that make it a little less challenging. Whether you're new to header building or you have a few sets under your belt, one of the biggest challenges in building a custom set of headers is knowing exactly how much material to order. And with the ICE Engine Works modeling blocks, you can pre-design and model up your headers, and that allows you to account for the room in the car as well as knowing exactly how much material to order. Each one of the modeling blocks represents 1 inch of material, and the ICE Engine Works Pro modeling kit comes with the necessary blocks to be able to mock up 3, 4, and 6 inch radius as well as straight tube. Another challenge in building a custom set of headers is knowing where to get high quality materials from. We buy ours from SPD, that's Specialty Products Design, and they have mandrel bends available from 1.25 to 4 inch, as well as 2 to 6 inch radiuses available. They also have a wide selection of collectors as well as other exhaust accessories. And when it comes to header flanges, nobody has a larger selection than SPD. Check them out at spdexhaust.com. We're going to give you guys a few pointers here on getting started with your custom header build. And a few things to keep in mind are the outside diameter and the length of your primary tubes. If you're building a fairly stock engine, you're going to be pretty limited on outside diameter options, and you need to check on the header flange sizes available for your engine. As far as the length, it's also dictated on what kind of car you're building and how much room you have available in the car. If you're trying to squeeze every last bit of horsepower out of a high-performance engine, you can get with SPD. They have a vehicle spec form that you can fill out. You can hand it to them and they'll create a custom recipe for coming up with the best application for your headers and what size primaries you need as far as the length and the outside diameter. Another thing to consider when building a custom set of headers is collector location. In this car we had one choice. The old headers exited out the front fenders and we were going to duplicate this on this build. But if it's up to you, there's a couple things you need to consider. The first thing would be primary length. Second thing would be exhaust system routing. And the third would be the vital components of the car that you need to make sure you steer clear from. Depending on what side of the car you're building the headers on, you may have steering, oil filters, the starter, and other vital wiring components that could easily be melted if the collector is mounted too close. One popular question when it comes to header building is how do you know which primary tube to start with? The rule of thumb I use is I start with the easiest tube to build, and that's usually the one that has the least amount of bends in it. I find if you start there, it gives you a good foundation for which to build the rest of your tubes around. We're going to explain to you guys now how to measure the tube length on a mandrel bend. If you look at this U-bend we have right here, the tube length is measured based on the center line of the tube. So if you were to draw an invisible line here, it would come around the center of the mandrel bend. So when you need to measure that, it's good to have a flexible tape measure. You can line it up with the center line of your tube, bend it to the shape of your radius, and it gets you a really close estimate on how long the material is in the mandrel bend. We have a mocked up header tube here. We're going to show you guys how you would know what angle to cut this mandrel bend at if you were trying to make this angle. So typically when I start a header tube, I get one end coming out of the header flange, and then I get another bend or straight piece coming out of the collector. Now you have two flat surfaces and you got to figure out what angle this is here. One simple tool, an angle finder. You can move the angle finder to match up with the flat surfaces of the tube, and that instantly tells you what your angle is going to be. So then you grab a mandrel bend. You can place one of the flat edges up against the flat side of the mandrel bend, and at the point where the other side touches the bend, that's where you need to draw a perpendicular line across your mandrel bend, and that's where you need to cut your tube. The first step in using the ICE Engine Works header modeling kit is adapting the header modeling blocks to your header flanges. And depending on the shape of your exhaust port, that can be done in the flange itself or in the first couple inches of your tube. And how these work is they utilize rubber grommets that expand out when you tighten up on the bolt. So what you do is you pop the modeling block onto the small side, and then you insert that in your header flange or the tube, tighten up on the bolt, and it holds it in there nice and snug. Now we're going to show you guys how to use the modeling kit to design up your headers. Now that we've got our right side header design modeled up, I'm going to show you guys how to use the Ice Engine Works modeling blocks to go from pre-made manual bends to a smooth flowing custom header design. The Ice Engine Works modeling blocks make it real easy to determine where your cut lines need to be on each one of your manual bends. And that is done using these arrows on the modeling blocks. And at the points where these arrows do not line up anymore is the points where your cut lines need to be. So when you determine where that point is, you can separate the modeling blocks, and these modeling blocks can be placed over your mandrel bends, and your lines can be marked, and that's where your cuts need to be. So the Ice Engine Works modeling blocks make it real easy to know what points to cut your mandrel bend at. But if you don't have modeling blocks, how do you know where to cut your bend? The theory in cutting a mandrel bend is that you always cut directly towards the tangent point of the bend radius. And what that does is it keeps your cut line perpendicular to your tube, which makes for a better looking product, as well as keeping optimal flow through your header tubes. Another tool that makes cutting mandrel bends a lot easier is this tube cutting jig from Ice Engine Works. Available are the spacers to match all of the different sizes of modeling blocks. And how it works is you slide your mandrel bend over the spacer, and you can rotate it to match any angle you're trying to cut. You lock it down in position, you place it in your vertical bandsaw, and you can cut right at the tangent point of the bend, which keeps your cut perpendicular to your tube. So one tip I've learned over the years of building headers is that once you get your cut out of the bandsaw, you end up with these little imperfections in the cutting surface that makes for not so good of a fit up. And the easiest way I found to true up that tube is to have access to a nice flat belt sander. With a belt sander, you can easily press the tube up to the belt as long as you have a nice flat platen on the backside, to be able to sand that surface nice and true so that when you fit your tube up, you can rotate it in any direction between the two pieces and still have a great fit. Let me kind of show you how that works. So as you can see here, with a nice true surface, When you fit your parts together, there's no gap, which makes for easier welding as well as less warpage in your tube. So hopefully the tools and tips in this video help the task of building a custom set of headers seem a little less challenging. If you're interested in any of these tools, click the link on your screen. And as always, give us a call or visit our website at tricktools.com if you have any further questions. Subscribe to our YouTube channel for more videos like this and other high-performance tools for the fabricator.